So in today's class, let us get started with probability. So there are some important terms you must know to start this chapter. So first is random experiment. Let us see what do you mean by random experiment. So an experiment, when repeated under same condition, such that its result cannot be predicted with certainty, but all possible results can be determined prior to the performance of experiment is known as random experiment. So this is random experiment. So an experiment when repeated under same condition such that its result cannot be predicted with certainty, but all possible results can be determined prior to the performance of the experiment. That is called as a random experiment. Next, let us see what do you mean by sample space. So sample space is nothing but total number of outcomes. So let us write the definition. The set of all possible outcomes. The set of all possible outcomes of a random experiment is known as sample space, and it is denoted by S. Each element in the sample space is called sample point. Now let us take independent events. So what do you mean by independent events? When two events are totally different and one does not affect the other, that is called independent events. Let us write the definition. So two or more events are said to be independent events if the outcome of one event neither influences other event nor gets influenced by the other event. Next, mutually exclusive events. Mutually exclusive events means there is nothing in common between two events. So let's see how do we write the definition. So two events are said to be mutually exclusive if the occurrence of one event stops the occurrence of the other event in the same trial of an experiment. So we can mathematically say A intersection B is equal to null set, which means probability of A intersection B is 0. So now let us understand something else about independent events. So we have taken the definition of independent events over there in the last page over here. But now let us see some additional thing about independent events. So let A and B be two events such that the happening of any one event does not affect the happening of the other event. So in such case, P of B by A is equal to P of B. P of B by A means B given A, which means already A has occurred. We are checking the probability of B. That is called as conditional event. Or P of A by B is equal to P of A. If this condition satisfies, then A and B are said to be independent events. Now we will see what are pairwise independent events. So the events A1, A2, A3, so on up to AN are said to be pairwise independent events if and only if P of AI intersection AJ is equal to P of AI into P of AJ. For all I is not equal to J, where I and J takes values from 1 to N. Now the same way let us extend it for 4 events. Pairwise independence for 4 events. So let us consider 4 events A, B, C, D. So what are the conditions? The conditions for pairwise independent events are P of A intersection B intersection C intersection D is P of A, P of B, P of C, P of D. And P of A intersection B intersection C is P of A, P of B, P of C. If you want to find P of A intersection C intersection D, that is P of A, P of C, P of D. If you want P of B intersection C intersection D, then it is P of B, P of C, P of D. So you can find pairwise independent for 4 events, for 3 events in this way. Now let us see what do you mean by mutually independent events. So if the probability is equivalent between the events, then it is called mutually independent events. So let's write the definition. So the events A1, A2, so on up to AN are known as mutually independent events if the probability of their simultaneous occurrence is equivalent to their corresponding probabilities. That is mathematically how we can write P of AI intersection AJ is equal to P of AI into P of AJ. Now P of AI intersection AJ intersection AK is equal to P of AI into P of AJ into P of AK. Now P of A1 intersection A2 intersection A3 intersection so on intersection AN is P of A1 P of A2 so on up to P of AN is true. Now let us cover mathematical definition of probability. So consider a random experiment in which an event E contains equally likely outcomes. The probability of an event E, that is P of E, is defined as the number of outcomes in favorable to E, that is N of E, to the total number of possible outcomes, or number of sample space N of S. That is, how can you write P of E? Formula for P of E is number of outcomes in favor to E by total number of possible outcomes, or number of favorable events by total number of events of the experiment. So this is the formula for probability. So which implies we can write it as P of E is equal to N of E by N of S. So now after writing the formula for probability, now you see the outcomes that are not favorable to E. Which are favorable to E, we will write it as P of E. And which are not favorable to E, those are N of S minus N of E. So we denote that by P of E bar. P of E bar denotes the probability of unfavorable events. If favorable is P of E, unfavorable is P of E bar outcomes. Then we can write P of E bar is equal to N of S minus N of E by N of S. If we separate it, N of S by N of S minus N of E by N of S. This get cancelled and you get 1 minus N of E by N of S. But we know that N of E by N of S is P of E. So that is 1 minus P of E. So that is P of E bar is equal to 1 minus P of E, or you can also write it as P of E plus P of E bar is equal to 1. So sum of favorable events and unfavorable events is always 1. Now let us say P of E is equal to P and P of E bar is equal to Q. Therefore, P plus Q is equal to 1, where P is called success, Q is called failure.